Also, we want to use new API like auto layout or UI stack views, and we are smarter now. So we know what to do better, and we know all the features and how they relate with themselves. And each of us knows that the 2nd of June 2014 was a big date. Apple released its own programming language, Swift, and we were shocked, but after a while we feel excitement. And we decided to write our app in Swift. So why Swift? So let's go back to 1984. Ghostbuster movie was released. Also, the Terminator movie was released. And the first Macintosh. So the first successful computer with user graphic interface driven by mouse. And also Objective-C. So Objective-C is 32 years old. It's much older than me. And do you use something older than 32 years old in your life? Me neither. But it was not the only reason. Timing was right. We know that Swift is the future of iOS, and also we know that the cooperation with Objective-C was pretty cool, so we can use Objective-C libraries. We also found out that clear syntax is super clear, and the newcomers from other platforms can learn quicker and make less bugs than in Objective-C. We can compare calling optional method of delegate in Objective-C and Swift, and it's super easy that you can find out that it's much easier in Swift.
Simpler.
Next thing is that we find out that Swift has much less boilerplate code, and it's super cool because if you have less code, you make less bugs. And we can compare creating simple type with read-only property. And in Swift, it just 3 lines with 14 in Objective-C. So Swift wins a lot. What we also find super cool is protocols. And we use protocols and protocols extension a lot. And we find out that in our Vue controllers, we have a lot of duplicated code, mainly for disabling swipe back gesture and enabling this again. And using protocol extension, we move out this, and we are controlling this by conforming to protocol. So if any of us want to disable swipe back, you just conform to protocol and it works. So we move out all the code for this to protocols. Another super cool thing is functional programming. Swift is not proper functional programming language, but it supports natural concepts like filter, reduce, map, flat map, and it makes our code cleaner. And also we can use smart one-liners like map, and you cannot use such one-liner in Objective-C because you will have in code review that it's not cool. So in summary, it took us 1 year of development. We have 140,000 lines of code in 2,000 files, but not everything went smoothly. We have problem with compilation times, we have problem with migration, and with Xcode. And how we handle these problems, Tomek will describe it.
Thanks, Wojtek. So let's get started with the compilation times. So everyone who works with Swift is aware of long compilation times. And probably our manager sees that when the compilation time is long, we are probably doing nothing, searching for some stupid things in the internet or doing something that is depicted here. But the reality is that when the compilation times are long, we are simply losing focus. It's harder to fix bugs. It's really important when we are fixing bugs, because instant feedback is something that is really necessary for fixing the bug really quickly. And with Swift, it was a bit hard, because the compilation times were really something that was scaring us. And for some people who are working with scripting languages, 1 minute compilation time, well, it's not compiling, but like 1 minute interpretation time is something that they can't accept. For us, it would be perfect if we had 1 minute compilation time. For people that are working with Swift, with smaller projects, 5 minutes is something that they are already complaining about. And our case was dramatically worse. We had 40-minute compilation time in the worst case. Of course, it was like worst case, compiling everything from scratch on a bit slower machine. But it was something that was making us angry, and we were trying to find some solution to reduce this time. Fortunately, we managed to reduce this time. We managed to halve this time. And we are like having much faster compilation now, which I will describe later. But this was something that was probably the biggest problem we had with Swift. And here you have some kind of comparison of different compilation times between different processors, for example. So it's already, in the beginning, we were surprised that some people got faster compilation. Then we discovered that it was like the difference between i7 and i5 iMacs. So if we had like i7, it was like 10 minutes faster in some cases. For i5, it was slower. But then there was another thing that surprised us. When we had really large project, and when we were compiling the project with whole module optimization, the compilation was much faster than when we were not using optimization at all. And it was like 4 times slower when we were not using optimization. So basically, we started to research this topic to find out what is causing these problems. And we found some possible explanation for that. So first of all, let's compare the differences between whole module optimization and when we are not using optimization at all. So first of all, when we are using whole module optimization, the Swift compiler performs the whole optimization on a module level. So it's not performing optimization based on a single Swift file, but it's doing that like on the whole module, on the whole framework level. And yesterday, Apple released a nice blog post about how whole module optimization works in Swift version 3. I think that if you are more interested in the topic, you should probably read it. I haven't had time to read it because just now Wojtek told me that they released this blog post yesterday. I will definitely dive into it, how it really works in details. But the difference, like the difference between whole module optimization and AllNone is, first of all, for us, with whole module optimization, we had faster build times. So it was like 10 minutes versus 40 minutes for the compilation from scratch. And there was one problem with that. With whole module optimization, incremental builds were not supported. It changed in Swift version 3, where they are claiming that this works now. But for Swift version 2, it didn't work. So this was something that was blocking us a bit, because every time we were fixing a bug, we had to wait these 7, 8, sometimes 10 minutes to compile the project. Then with whole module optimization, the debugger is not working that well. In fact, it has no debug symbols. Stepping may behave oddly. So this is something that, it's something that it generates problems, because every time we want to debug something, we have to turn off the optimization. And on the other hand, with AllNone, we have slower compilation time and incremental builds. So this was more like a decision. If you want to wait longer for the first time and then have incremental builds, which are not that perfect, because anytime we tried to change something in extension, for example, it triggered another compilation from scratch. So this is some problem with Swift compiler that has problem with determining the dependencies. So it triggered the compilation if we were changing something that had lots of dependencies. So it was like provoking the compilation from scratch. And we started to dive into how this whole module optimization works, and the bigger our project was, the more problems we had. So up to Xcode 7.2, for example, we had a problem that our project stopped compiling at continuous integration server. And we were surprised, because it worked locally. It was like a typical scenario. It works for me, I don't care, but the CI simply didn't work. But then we started to investigate this topic, and we found out that when whole module optimization is invoked, the compiler gets all the Swift dependencies of the project in one line. Well, they changed it now. Now they have some file list arguments, so now this problem was fixed, but this problem was still valid like half a year ago when there was, like, the bug was still there. So when we were putting all those files in one command line and all those files used absolute path, then the compiler was simply, the command line argument was too long and it exceeded the limit of OS X, and it simply crashed. Well, it simply returned some error. I don't know. I don't remember exactly if it was an error or if it was a crash or something, but it simply didn't work. And we spent like a week to discover that this was the real issue. And we were doing that like by making some experiments, like adding files, and when we removed some files, it worked. When we added those files, it didn't. And then someone moved this project into the directory that had like a smaller absolute path, and it suddenly started working. So for some time, it was our solution to compile the project in a directory that has smaller absolute path. But now they fixed that. But they fixed that, and they broke those dynamic code injection for projects that are larger than, I think, 300 files. So you can like blame us for that, because we reported this as a bug also to them, and they fixed that. And the dynamic code injection is not working anymore for projects with more files because of this file list argument. Okay, there was another problem with AllNone option. And when you investigate how AllNone option works, it works in a way that it compiles every single Swift file independently. And when in Xcode, when you expand this command, then you see like the Swift-C compiler that is invoked. And it, again, contains the Swift file plus the dependencies. And in our case, the dependencies were all the files of a Swift project. So we had a single file together with a list of 2,000 files that were passed there. And then we start to analyze the problem. And we've noticed that each file is compiled, the compilation time of a single file takes from 1 to 2 seconds. And it was surprised when we had 2,000 files, it easily adds up. And then we had a suspicion, because we noticed that this compilation time is more or less the same for every file, even if the file had only like a dummy class. So we had a suspicion that the problem is not in the compilation of code itself, but it's in processing probably of those dependencies, of those arguments that are passed into the Swift C. So reducing this number of files would help a lot. But this was a bit hard when we had like a single monolithic app without frameworks. And it was a decision which moved us to implementing frameworks in our app. I will mention that a bit later. So in the beginning, to make the improvement, we were trying to follow some of the tweets. Well, there were some kind of tweets that were popular. People were complaining about some functions that took more time to compile. And there was a blog post that they published some script that was gathering those culprits to find the functions that were compiling a bit longer. In fact, we ran that script and we found some potentially dangerous functions that took a bit longer to compile, but that was not enough to fix our problems. It was like a small percent. It didn't help. So the only solution was introducing frameworks. With frameworks, we could decompose our project into smaller parts, which had less dependencies, which could a bit simulate incremental builds because we didn't have to recompile the whole project from scratch. So we were waiting with that for the decision to drop the iOS 7 support because we couldn't introduce those frameworks until we were supporting iOS 7. But with dropping of iOS 7, we could finally migrate to frameworks approach. So we converted one monolithic app into several frameworks. We have like the framework which is responsible for implementing primitive parts of the app. We have the service layer which communicates with the backend, for example, and contains a lot of automatically generated code which simply doesn't change that often. We have utility kit that simply provides some helpers and some common extensions. We have core kit, which is like the base core of the app. And we have the glue kit, which implements some kind of graphical user interface parts, components, and navigation. So with that, we reduced compilation times. It's something that it's still big, but for example, for AllNone, we reduced the compilation time to 13 minutes, and it's like on the i7 processor, for example. And this is something that it's already acceptable for us because this is like the compilation time for the first pass. And then when you are making more changes, you can leverage the incremental builds. You don't have to recompile all the framework. So this is something that we can accept. Incremental builds work properly. Because we are passing less dependencies to the compiler, we don't have this problem with long invocation of a single compilation step. But frameworks, for us, they also have some pitfalls, which I would like to mention. First of all, they were introduced post factum. So we had to convert existing code into frameworks approach. So we had some dependencies, which we had to cut. So we had to decouple the code. And then we had to, for example, annotate classes with proper scope prefixes like public. It was mainly the decision between public and internal. Because when you are exposing some functionality into framework and you want to use that from another module, it has to be public. So we had to like revise the code, what should be public, what should be kept internal. So this was the problem. Then we had to add missing imports. And we didn't want to add all the imports of all the frameworks to every file because we were afraid that it may trigger it may trigger the unnecessary builds for the dependencies that are really not dependencies because we didn't know exactly how Swift compiler works. So we inspected the code and we added only important imports. And then we had some problems with Xcode related to frameworks, which I will mention in the end in the part related to Xcode. So with frameworks, we got much faster compilation times. We don't have to rebuild the whole app every time. We have less coupled code, so we decompose the dependencies. Either we extracted those dependencies to protocols that are later used by the components, implemented by the components outside the framework. Those frameworks can be tested separately, so we could move the tests to frameworks, and it was also some kind of benefit that we didn't have to have like a big list of tests related to the application itself, but they are moved into framework part. And then we don't have to recompile those frameworks every time. So this is also a big benefit. Okay, that's enough for the frameworks, and now let's move on to migrations. Well, we started our project with Swift version 1.2. And we had 2 attempts for the migration. The first one was more like to evaluate the time that is needed to make the transition. And the second one was more like the real process. And totally, it took us 3 weeks to migrate the code. And it was not a trivial task because we had to deal with... Yes? The code base was about between 1,500 files and 2,000 files, something like that. I don't remember exact number of lines, but it was within this range. So it was quite big. And then I will describe this process in details a bit later, but then from Swift 2.1 we were migrating to Swift 2.2, and this process was straightforward because there were not so many changes and the conversion tool behaved more or less properly. And the migration process was divided into several parts. The first part was auto-migration tool. And in our case, auto-migration tool was running 9 hours. And it's running in a way that you don't see any progress. So you are scared if the process suspended or if it's not responding. And then you should also be aware that when you are having, for example, auto-suspension or the computer is put into sleep mode after some time, you should either use caffeinate or turn that off, because otherwise you will come another day and you will see the same result and you are worried if something was working or I don't know if the process takes so long. So we discovered that after 1 day that the computer was suspended. But then the process took 9 hours. After 9 hours, we got 30,000 errors or something. I don't know. No, maybe not 30. Some thousands of errors, yes? Errors or warnings, and we had to fix them manually. Most of them were trivial errors, but we had to deal with them. So, yes, and after that, we had to revise the code because, for example, the auto-migration tool puts lots of force unwraps in lots of places. So we didn't want to have force unwraps, and we preferred to use optionals. And like to use iflets or the operators to work with optionals properly. So we had to revise this code, and we had some unplanned tasks. And the task was finding a workaround to Swift-C because it crashed again. And it crashed in a way that we couldn't build our project. I will describe it later. And after that, we had the code review. So this process took more or less three weeks. So what were the problems with the migration? First of all, the biggest problem is that it didn't solve all the issues we had. It only solved a percentage of problems. Then, for example, the Xcode 7.2 had a crash that we had to work around. I will mention that later. For example, when we are migrating between Swift 2.1 and Swift 2.2, it generated lots of warnings. And those warnings can quite easily get out of control. Because when you have lots of warnings, you simply ignore more warnings when they are generated by your code. So this is something that you should take care and pay attention because fix them as soon as possible. Otherwise, they will go out of control. And then, as I mentioned, we had to manually review the code. There were force unwraps that we didn't want to have, so this was also problematic. The other problem was that when you have different versions of Swift, you are mixing different patterns. For example, Swift 2 introduced guards, and we didn't have guards in the first version. And when, for example, we started to use those guards, the old code didn't have guards, and it was a bit misleading for new developers that some parts of code have guards, the other not. So there was a bit like inconsistency between legacy code and a new version. And the other problem was that all the developers had to migrate at once. We didn't want to have feature branches which are still based on old code. So we did this transition in a holiday period when there were not so many developers in our team, so we could make it faster and less people were affected. And as a result of migration, for example, backporting the bugs is a bit harder because if the problem is fixed in the newer version of Swift, you have to backport it sometimes somehow to the older version, and you had to do it manually, translate the code because Git simply didn't allow to cherry pick those commits, and this was also problematic. Okay, and now last of the problems we had with the compiler. It was the problem related to large number of files we had in a project. And you may ask, why do we have so many files? Well, first of all, we have lots of auto-generated code that adds pretty easily. We are generating the code for the service layer, so we are not writing this code. We are trying to follow single responsibility principles. So we are trying to write small classes that are having a single responsibility. Those classes are put into separate files. In the beginning, we're thinking that this is a good idea, but then when we had lots of files and the compilation time was going dramatically up, we changed a bit our approach to having every single class in every single file. But when we started that, we were putting everything in a single file, all the extensions, all the protocols. And this is why we had so many files. So it adds up pretty easily. And we had a problem with whole module optimization when we migrated to Swift 2 and we were using Xcode 7.2. The problem was that when we were using whole module optimization, this list of files, of all the files in the project, was put into a single command, Swift-C invocation. And it was not the problem with the long argument list in a long command line length in OS 10. It was another problem. We noticed that when the command line length is, the number of arguments is long enough, Swift-C simply crashes and it's not invoking anything. It simply crashed with segmentation fault. Unfortunately, Apple open sourced Swift-C 5 days after we had that problem, so we started to check the source code and we traced down the problem. We discovered that the crash is in POSIX spawn function that forks the processes, and when it gets too many arguments, it simply crashes. And we reported that problem to Apple, but in the meantime, we wanted to find some kind of workaround which would allow us to work with version 2 of Swift. And it was not the day when you could simply swap Swift-C in Xcode. It was still when Swift was embedded into Xcode. So we had to find a workaround. And we noticed then when you modify the number of parameters, the number of threads in Swift-C invocation, and you change that value to 0, which is supposed to probably be invalid value, Swift-C is not using POSIX spawn, it uses fork, which doesn't crash. The problem was that you couldn't modify this argument from Xcode itself. You had to directly pass this argument to Swift-C. And it was not that trivial, so I wrote a wrapper script that simply modified this. It acted as a proxy between Xcode and Swift-C and modified this parameter and allowed for the compilation of the project. And with that, for some time, we could work with migration and with verifying if the project works properly after the migration. And within 2 months, probably Apple fixed that problem. So it was like an intermediate solution, just not to lose our time. So that was something that helped us. And there was some problem with Xcode that we had. In the beginning, in the early days, we were seeing lots of source kit problems, source kit service error. Later, Apple got rid of this screen, but with current version of Xcode, we don't see that pretty often. There are some problems that we are losing coloring of syntax, which is like it's a side effect of source kit crash. But well, it's mainly in situation when you're using more complex code patterns, like some functional patterns or some generics. Then we notice that the probability of crashing the compiler is much higher when you are using some smarty one-liners or some generics. Then the probability is higher. But the compiler got more stable, and now it's more convenient to work with it. The second problem was that refactorization was not supported. In the beginning, we tried Upcode, but in the early versions of Upcode, it was not working. Now it works a bit better. You can work with basic refactorization techniques, but it's still not as good as in Objective-C for us. And then the problem with LLDB, it's with the debugger, it's not working very well, especially when you are using whole module optimization. And when we introduced the frameworks, for us, the biggest problem now is that within the frameworks, we are not getting any code completion on Xcode 7.3. We are not getting any syntax hints. It's simply not working. But it works surprisingly on Upcode. So if you need code completion within the frameworks, if you need navigation in the source code, it doesn't work inside frameworks in Xcode, but it works in Upcode. Okay, so what's next? Well, we are planning migration to Swift 3, but we are not yet there, and we don't know when it's going to happen. But for sure, we can expect quite a lot of problems, and those problems, let's see, mainly because of the grant renaming and all the new changes. But anyway, we would love to work with Swift 3 now, but this process is not that straightforward. I think that for most of you, but in case of large projects, it's even harder. And having in mind that you have lots of developers, it's even more complex. Okay, so now you may ask if we like working with Swift, if we could go back in time, if we would rewrite the app in Swift. I think that the decision would be still go with Swift. We don't regret it for sure. We could successfully deploy the app that is available in App Store. All our developers, we are really enthusiastic to have a chance to work in Swift in an early version, when we could interact with people from Apple to report the bugs, and we are really happy to work with Swift. In the language that still evolves, it has some problems, but all the young languages, they have problems. And without support from the developers, they can't get popular. So we are still really enthusiastic about this language. After migrating to Swift, we have less crashes, especially those crashes that were some kind of run crashes. We can faster prevent those crashes on the compilation time. We have less errors, especially those that were resulting to some kind of force unwraps. Not force unwraps, some referencing nil pointers, and it's much easier to prevent those errors on the compilation time. And we could reach less code because Swift is less verbose, it has more compact syntax, it doesn't have header files. So it was like smooth, the code is less compact. So all in all, we think that the decision was really good that we are working, especially for the developers. We are really enthusiastic about that. We know that especially when we talk with the developers, when they are working with Swift, they don't want to go back to Objective-C. If you work like for 1 year in a Swift project, you know all the good sides of Swift, and you don't want to go to this old technology that is like more than 30 years old. And you know that the future is Swift, and it's nice that there are companies that are incorporating Swift in their products. In the beginning, the decision may be a bit risky, but in the end, the process really went quite well. There are some side effects like migration, long compilation time, but we think that this will improve, and when there are more apps, the problem may be when there are more people that are engaged into Swift, all the problems will get faster solved, especially now when Swift compiler is open source. Okay, so thank you for your presentation. I hope that you enjoyed it. If you'd like to work with us, we have some opening positions. And I hope that you enjoyed the presentation, and thank you.
When you're planning to move to Swift 3, you also think it will take 3 weeks, or it should be easier now when...
Well, frankly speaking, we don't know because we didn't make any estimation. Probably we'll run some kind of first step to see how long does it take for the migrator to complete and how many errors it generates, and then we can make some evaluation. Of course, there may be some Of course, there may be some problems that we may not know before we start the process, but I wouldn't give any estimation now.
Hi, I have 2 questions if you don't mind. First one, do you use your frameworks cross projects, or this is only frameworks for this one project?
I don't know if I can answer this question, but we have frameworks that are dedicated. So
okay, so my question is, how do you manage these dependencies? Do you use some tool, or you just use Xcode workspace for this?
We are using Cocoa pods.
Okay. And second questions, what are your experiences with continuous integration for this code base?
Well, when we had long compilation time, the continuous integration was not working very well for example, on pull requests, because it took too long to process that and get some kind of feedback. So it was not working as we would like it to work, but now we are trying to introduce that in pull requests so that we hope that it will work, but it's still, we are having continuous integration that is making the tests every certain period of time, but it's not yet based on pull requests.
Okay, so I don't know if you can answer this question, but what tools are you using for continuous integration?
I don't know if I can answer. Probably not.
Maybe you can nod your head if you're using Jenkins.
No.
Okay, thank you.
Thank you.
What made you switch to Swift so early? Weren't you afraid that next versions of Swift will introduce breaking changes and you'll have to spend time on it?
It was not my decision, so I can't say what was the explanation.
All right, thank you.
I joined the project when it was still like already developed, so I can't answer to that question correctly, probably.
Okay, thank you.
Any other questions? Okay.
Hello, Maciek. Is the continuation of the first question? Did you have any initial estimates for the migration, or did you just?
Yeah, for the first migration, we had some estimation. It was based on the first running auto conversion. We got the number of bugs. We put one guy that was trying to fix them manually. He reduced them by a given number. Then he noticed that those bugs are more or less, those errors are more or less similar. So we had some estimation, but we had to reevaluate it when we tracked this in a compiler.
Okay.
And such things like those bugs, they can simply break any of your estimations. Because we were even not sure if we would accomplish that task, because it was something that until the last day we're not sure if it's going to work. And we would have to stop the migration, wait for it to be fixed.
Okay, and maybe another question, because there's a big regression risk in such transition from one version to another version with some magical automatic tools and then manual migration. What did you do to reduce the regression risk? Any QA testing, deep testing?
Yeah, we have QAs, we have testers, we have tests, automated tests, UI tests. So yeah, the code coverage, the test coverage is pretty good. So of course, the regression risk is always, but we didn't have I think that we didn't have any spectacular crashes or something when we migrated the code due to the migration itself.
Okay, thanks.
Are there any more questions?
Coś odpowiedz.
So hi, do you write everything from scratch, or you use some third-party libraries?
Yeah, I think that we have some third-party libraries. So
Okay, so how you maintain this code if you want to migrate to Swift 3?
We are still not planning it now. I think that it may introduce some problems because some libraries are still on Swift 2, some of Swift 3. So we know that it's a problem, and we would like to wait a bit longer until we can start with the migration itself.
Okay, thank you.